Hubble just tracked an object moving through space at a velocity so extreme that our sun's gravity cannot hold it. And what scientists found when they studied where it came from has opened a question that the entire astronomical community is not yet prepared to answer. The Hubble Space Telescope has spent over 3 decades observing the universe, but some of its most scientifically disruptive contributions have come not from looking at distant galaxies billions of light-years away, but from tracking objects passing through our own solar neighborhood. And what Hubble's precision astrometry capabilities revealed about the interstellar object Oumuamua remains, to this day, one of the most genuinely unresolved mysteries in modern astronomy. Oumuamua was first detected on October 19, 2017, by the Pan-STARRS telescope at the Haleakala Observatory in Hawaii. Initial calculations of its trajectory immediately revealed something unprecedented. This object was moving on a hyperbolic path, meaning it was not gravitationally bound to our sun. It had come from interstellar space, passed through our solar system, and was already leaving. It was the first confirmed interstellar object ever detected passing through our solar system, a visitor from another star system that humanity had approximately 11 days to observe before it moved beyond the reach of ground-based telescopes. Hubble was immediately redirected toward Oumuamua, and what those observations revealed shocked astronomers at a fundamental level. The object was accelerating, not decelerating the way physics demanded it should, as it moved away from the sun's gravity, but actively accelerating beyond what any gravitational model could account for. This non-gravitational acceleration was real, measurable, and confirmed across multiple independent analyses. The standard explanation for this kind of behavior in a comet is outgassing, when solar heating vaporizes volatile material on the surface, creating jets of gas that act like a natural thruster. But Hubble and Spitzer Space Telescope observations found no detectable outgassing signature around Oumuamua. No coma, no tail, no gas jets. The acceleration was there. The explanation was not. The object's shape added another layer of mystery. Brightness variations as it tumbled through space suggested an extreme geometry, either highly elongated like a cigar, with a length-to-width ratio of approximately 5 to 10 to 1, or potentially flat like a pancake. Neither shape is commonly produced by natural solar system processes. Neither had been observed in any previously catalogued small body. Harvard astronomer Professor Avi Loeb and his colleague Shmuel Bialy published a paper in 2018 in the Astrophysical Journal Letters, proposing that one possible explanation for Oumuamua's anomalous acceleration was radiation pressure, the gentle push of sunlight, acting on an object of very low mass relative to its surface area. They noted that if Oumuamua were a thin, flat structure with a very high surface-to-mass ratio, sunlight alone could account for the observed acceleration without requiring outgassing. Their paper noted this was consistent with a natural phenomenon, but acknowledged it was also consistent with an artificial thin membrane, a light sail. This is not fringe science. Professor Loeb holds the longest tenure of any chair in the history of Harvard's astronomy department. The paper was peer-reviewed and published in a respected journal. It did not claim Oumuamua was artificial. It stated that the data was consistent with that possibility, among others, and that the scientific community should take the question seriously rather than dismiss it. The broader scientific consensus has leaned toward natural explanations, including a 2023 paper published in Nature proposing that Oumuamua could be a fragment of a nitrogen ice body similar to Pluto's surface, which would explain both its flat geometry and its outgassing-free acceleration as the nitrogen ice slowly sublimated invisibly. However, this explanation also has critics who point out the statistical improbability of such an object reaching our solar system at the observed rate of interstellar object detections. What Hubble's tracking of Oumuamua ultimately delivered was not a clean answer. It delivered a confirmed anomaly, a measured physical behavior that does not fit neatly into existing models regardless of which natural explanation is applied. And in science, confirmed anomalies that resist clean explanation are frequently the doorways through which the next generation of understanding eventually walks. The Vera Rubin Observatory, currently completing commissioning in Chile and expected to begin full science operations in 2025, is projected to detect interstellar objects at a dramatically higher rate than previous surveys, potentially identifying one or more per year. Each new detection will either reinforce or challenge what Oumuamua's data suggested. And this time, humanity will have more warning, more instruments, and potentially the ability to direct a fast response mission toward an interstellar visitor before it exits the solar system. Oumuamua is gone, currently approximately 5 billion kilometers beyond the orbit of Pluto, and moving further away every second, at a velocity no spacecraft we have ever built could match, without years of advanced preparation. But what it left behind is a data set that continues to generate scientific papers, active debate, and one question that has not been definitively closed. Something huge came through our solar system from somewhere else, behaved in ways that our best models still struggle to fully explain, and left before we could get close enough to truly understand what it was. So here is the question I want you to sit with and answer in the comments. Given everything the data actually shows about Oumuamua's anomalous acceleration, extreme geometry, and absence of outgassing, do you think the scientific community has been too quick to settle on natural explanations, or do you think the extraordinary claim of an artificial origin genuinely requires more extraordinary evidence before it deserves serious consideration? Follow this page right now if questions like that are the reason you find science genuinely exciting, because we cover the discoveries and the unresolved mysteries with equal honesty every single week.